Hello friends, the topic of this video is support vector machine. So before starting the support vector machine, in machine learning there are three types of learning: supervised learning, unsupervised learning and reinforcement learning. In supervised learning the labels are provided to the data. In unsupervised learning the labels are not provided to the data, and in reinforcement learning uses the agent, and agent take the feedback of the action and then appropriate action will be taken. Now, support vector machine is a supervised machine learning algorithm which is generally used for classification and regression, but its most of the application are in classification of the data. So, before starting this algorithm, let's take this example. Suppose uh, this is the input data. The here the labels are not provided. So this is square and these are the circles. So it is provided to the training model. So model gets trained, and then whenever you provide the new data, let us say this is square, this is circle. So output will be circle and square. So this is how the machine learning works. So this is supervised learning because here the labels are provided. So now same thing we can draw in support vector machine. So let us see how to draw it. So let us take the x and y plot, and we perform the classification. So now here we did the classification. These are the square, these are the circles. Now if you want to differentiate it, what we will do, we will draw one straight line here. So there will be accurate classification. Now this line is nothing but decision boundary which differentiate the circle and square. So this decision boundary is known as hyperplane. Okay. Now, if you look at these 2 points, this is nearer to this hyperplane and this is nearer to the hyperplane. So what I will do, I will draw one more line which will touch these points. So here I draw one line, here also I draw one line. So here this line is close to this point, this line is close to this point. So this is nothing but distance d1 and this is nothing but distance d2. Now if you combine distance d1 and d2, this is called as margin. Okay, if you combine distance d1 and d2, this is called as margin. Now where are the support vectors? These points, these closest points are nothing but the support vector which will create this complete plane. Okay, so these are the support vector. Now, and this is the margin, this is the hyperplane. Hyperplane is nothing but the decision boundary which differentiate the two entities. So this is how the SVM works. So in SVM, hyperplane is created to differentiate between the two entities, and then margin will be also created with the help of support vector. So this is how the support vector machine works. Now I will tell you what are the categories of support vector machine. There are two categories: linear SVM and non-linear SVM. So let us see what is linear SVM and what is non-linear SVM. So I will draw one more graph here. Circle, circle. So if you compare these two diagram here also there is differentiation between circle and square, but in this diagram we cannot draw any decision boundary or hyperplane. It is not possible. Okay, it is not possible to draw the linear hyperplane here. So this is called as non-linear SVM. But if you compare this diagram here, there is we can draw the hyperplane here. So that's why this type of diagram is called as linear SVM. Okay, now the next question is, we can draw these types of line also, we can draw this type of line also. So why we draw this type of line? So the answer will be in next diagram. I will draw the two diagram and I will tell you what the difference between uh, the margin, how to select the margin, and what is the importance of margin in SVM. So let us see the two diagram again. Okay, so this is the hyperplane and these are the support vectors. So I will draw this line again, I will draw this line. This both thing is nothing but margin. So I will give this margin as margin M1. Then there is one more diagram. So here if you look at the margin, again you can draw the margin, but length of the margin is M2. So if you measure the margin length, this M1 is greater than M2. M1 is greater than M2. So now what is the importance of margin? The more the margin length, there will be more better prediction, and if there is better prediction, the model will provide better accuracy. So that's why you have to select the diagram which will provide the better prediction. So how to select the model which provide better prediction? You have to calculate the length of the margin. If margin length is more, then you have to select that model. So that's why there is lot of importance to the margin in the support vector machine. So this is how you have to this is how the support vector machine works. So that's it for this video. I do hope you understand the importance of support vector machine and how it works. If you like the video, then please subscribe, like and share. Thank you.